Letter A is represented as letter A is represented as 1000001 in ASCII. Right? What is the ASCII code for letter F? A represent කරන්නේ 1000001. 0 පහක් තියෙනවා and 1. Then we have to find the ASCII of letter F. Do this one and give me the answer. ASCII value is given for letter A, then we have to find the ASCII value of letter A.
So one
Yes.
zero 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 1 1 0.
1 0 0 0 1 1 0. 1 0 0 0 1 1 0. Let's see. Any answer other than this? Hello. Now what we need to do first, the binary value is given for A. 1 0 0 0 0 and 1. Now we have to find the decimal value of A, right? So fine. This is 2 to the power 0, 1, 2, 3, 4, 5, 6. This is 64, ne? 64 plus මේටි කොහොමද බිඳුව එන්නේ? ඒ නිසා 0, right? Then 1 into 2 to the power 0. That is 1. That means 65. 65 can equal a decimal value, right? 65 is the decimal value of A. Then we have to find the decimal value of F. A, B, C, D, E, F. A is 65. F is 70. Now we can find the binary value of this 7, right? How to find? 70, 0, 1, 1, 0, 0, 0, 1, right? Right this way. 1, 0, 0, 0, 1, 1, 0. This is correct, right? This is the ASCII value of F. This is how we find. First, we need to find the, if the binary value is given, we have to find the decimal value. From that decimal value, we can find the relevant decimal value for F, right? Then convert that decimal into binary. Why? We have to represent ASCII in binary form. There should be 7 binaries in ASCII. මොකද අපි character එක අපි කිව්වා represent කරනවා binary values 7කින්. ඒ නිසා there should be 7 binary numbers. Right? Got? Right. Now, we use this coding system to represent characters and special things in computer, right? Then I told you that everything we input from the input devices to the computer, it is converting into relevant binary value, right? It can be an image, it can be an audio, it can be a video. All the things should convert into relevant binary value. අපි හිතමු this kind of flower. මලක් තියෙනවා මේ වගේ, right? How to represent this colors in computer, right? This flower image, right? When you zoom an image, you can see there are a lot of tiny squares in this image. අපි zoom කරලා බැලුවොත් computer එකේ තියෙන image එකක පොඩි චූටි කොටු අපිට පේනවා, right? So in that tiny square there is a relevant color. There is a color, right? Each and every tiny square has a relevant color. For that color there is a relevant binary value. එතකොට මෙතන තියෙන කලයකට relevant binary value එකක් තියෙනවා, right? එතකොට මෙතන තියෙන value එකට sorry කලයකට relevant binary value එකක් තියෙනවා. මම for example so each and every square there is a relevant binary value, right? So when we represent this full image to computer, there can be set of binary values like this, right? අපි මේ වගේ image එකක් represent කරනකොට මේකේ ලොකු මේ වගේ binary value set එකක් තියෙන්න පුළුවන්. මොකද හැම කලයකටම binary value එකක් තියෙන නිසා. උදාහරණයක් විදිහට, right? Each and every tiny square has a relevant binary value. හැම dot එකකටම තියෙනවා අදාළ binary value එකක්. ඒ විදිහට තමයි computer එකේ මේ මල සම්පූර්ණයෙන් represent වෙන්නේ, right? ඒතර මේකට අදාළ binary value එකක් තමයි යා තියාගන්නේ. අපි sound එකක් ගත්තොත් sound is a right, so we can take the sound as a analog signal. මේ wave එකේ හැම point එකකටම value එකක් තියෙනවා. අපි හිතමු මේ point එකට value එකක් තියෙනවා, right? For example, this point has a binary value. Then this point has a binary value. මම උදාහරණයක් කියන්නේ. Each and every point has a binary value, right? That is how this sound is keeping in computer with those binary values, right? That is a idea. Anything we input from the input devices, it can be an image, it can be a sound, it can be a video, it can be characters, it has a specific binary value, right? That is the idea. Okay, that is the end of this number systems lesson. Do you have any questions and anything need to clarify? මොන හරි තියෙනවා නම් ප්‍රශ්නයක් මේකේ තේරුම් නැති තැනක් හරිද? ආයෙ පොඩ්ඩක් explain කරන්න කියනවා නම් මට කියන්න. right? මොනවද තියෙන්නේ? අලුතෙන් join වුණ අයට අපි ආයෙ ඔන්න දවසක් දාලා මේක පොඩ්ඩක් පාඩම කරන්න පුළුවන්, right? Any questions? මොන හරි තියෙනවද? කියන්න බලන්න. අලුත් අය වුණාට කමක් නැහැ. right? Okay, okay. Then we'll move for the next section. Listen. Logic gates. Boolean expressions. Boolean function keno, expression keno. Logic gates and Boolean expressions. Right? This is a very important lesson and interesting lesson. Right? This is not difficult. Huh? Right? Why we need logic gates and where we use logic gates? Right? Why we use logic gates and where we use logic gates? What is the meaning of logic? තර්කණය logic එකක් කියන අපි කියනවා සිංහලෙන් තාර්කික කියලා. තාර්කික ద్వාර. Right? So we know that in let's say this is the CPU, right? In CPU there are three main parts. What are those? CPU consists of three main parts. What are those? Remember?
Use memory register.
One is ALU.
Arithmetic and logical.
Memory registers. Right? ALU is arithmetic and logic unit. Arithmetic and logical unit. So they are logical part. Arithmetic and logic, your logic unit. Arithmetic means there is a mathematical part plus logic part, right? So that logic part is doing by this kind of logic gates. We use logic gates to do the logical part. And therefore, CPU consists of lot of logic gates. ඒ කියන්නේ CPU එකේ logic gates ගොඩාක් තියෙනවා. මේ logic gates වල තමයි මේ logic එක control කරන්නේ. Right? Therefore, CPU consists of lot of logic gates. So, and every circuit that you are dealing with, there are lot of logic gates. අපි ඕනම circuit එකක් ගත්තොත් අපි හිතමු AC remote AC එකක control කරන එක අපි හිතමු. So let's say controlling the AC, there's a remote control. By pressing the remote control, something is happening inside the AC, right? So we give some instructions and according to that instruction, it will do something logical, right? It will increase the fan speed. It will control the AC level, right? Those kind of things is doing by that circuit. How it is done? It is done by this kind of logic gates. There are a lot of logic gates, right? Inside these circuits, there are a lot of logic gates. So that is the reason we understand this logic gates. That's the reason. Reason is that now we are in the circuits, there are logic gates. It can be a central processing unit. It can be another circuit. There are a lot of logic gates, right? That is why we need to understand this one. ඒකයි අපිට logic gates අපි ඉගෙන ගන්න අවශ්‍ය වෙන්නේ. right? right. අපි මේ topic එක ලියා ගමු. right? topic එක ලියා ගන්න. logic gates and Boolean expressions. Right? So in this lesson, we discuss about one is basic logic gates. Second one is combinational. Logic gates. Right? Combinational logic gates. So you have learned about these basic logic gates, I think. Grade 7, 8. You have learned about this basic logic gates. What are basic logic gates? Can you tell me? Basic logic gates? Right? How many logic gates are there? Basic. There are AND gate, right?
OR gate,
OR gate, not gate. AND gate, OR gate, not gate. These are the basic logic gates we learned and we are going to learn this one as well. අපි මේකත් ඉගෙන ගන්න යනවා. මොකද මුලින්ම අපි කරන්න ඕන නිසා. AND gate, OR gate, not gate. Right? And we should know the relevant truth table for the gate and the relevant symbol. Right? So what is the meaning of this combinational logic gates is it's a kind of, let's say, AND gate and not gate, OR gate and not gate. Right? එතකොට අපි කියනවා AND gate එකයි not gate එකයි එකතු වෙලා අපි combinational gate එකක් හදනවා. Right? NAND gate එකක් කියලා මම ඉස්සරහට කියනවා. It's a NAND. Right? Not and that is NAND. Not and O, that is no, NOR. Right? Kind of combinational logic gates we discussed from this lesson. So these are basic logic gates, right? Take this down. We are going to discuss basic logic gates and combinational logic gates. So basic logic gates are AND gate, OR gate and NOT gate. AND gate, OR gate and NOT gate. right? අපි අද එක logic gate එකක් අපි discuss කරලා අපි පොඩ්ඩක් ඉතින් නවත්තමු, right? Basic logic gates are AND gate, OR gate and NOT gate, right? So first we discuss about the AND gate, right? AND gate. Now the symbol of AND gate, if you can remember, the symbol of AND gate is like this. Symbol is like this, right? Symbol is like this. So when we consider inputs are A and B, right? Q for the output, we call this as the Boolean expression as well. So symbol of this one is A dot B. When there are two inputs called A and B, so we can write this as Q equal A dot B. Q is the output. Q equal A dot B. A dot B. මුලින්දම මේක හොඳට පැහැදිලිව දැනගෙන යන්න. එතකොට ප්‍රශ්නයක් නැහැ. A dot B. Right? Q is equal to A dot B. Right? So then I am going to write the truth table for this one. Truth table. Right? How to write this truth table? So when there are two inputs, right? When there are two inputs, here there are two inputs, right? There are two inputs, then this can have 2 to the power 2 combinations. That means 4 combinations, right? අපි බලමු ඒක. right? ඔන්න මෙහෙමයි වෙන්නේ. ඒ කියන්නේ මේ A වලින් B වලින් එන්නේ සිග්නල් එකක්. ඒක 0 වෙන්න පුළුවන්, 1 වෙන්න පුළුවන්. This can be 0, this can be 1, right? So there are two inputs, right? So therefore there can be 4 combinations. This is input A, this is input B. Now what are the combinations here? There can be 4 combinations. 0, 1, 0, 1. 0, 0, 1, 1. නේද? කොහොම මෙච්චරයි දෙන්න පුළුවන්. මේ වගේ combinations හොයන විදිහ මම පස්සේ ආයේ table එක මේක ගන්න විදිහ මම කියලා දෙන්නම් ආයේ. Right? So this can be 0, this can be 0, this can be 0 and this can be 1. This can be 1 and this can be 0. This can be 1 and this can be 1. Those are the combinations that can be having this and gate. මොකද A බිඳුව වෙලා B බිඳුව වෙන්න පුළුවන්. A බිඳුව වෙලා B එක වෙන්න පුළුවන්. A එක වෙලා B බිඳුව වෙන්න පුළුවන්. A එක වෙලා B එක වෙන්න පුළුවන්. ඔච්චරයි වෙන්න පුළුවන් මේක. Right? So now we have to find the relevant output to this combination. ඒ කියන්නේ අපි කියනවා මේක අපි Q dot A dot B. Q equal A dot B අපිට හොයන්න ඕන. Right? So when A is 0, B is 0 in the AND gate, output will be 0. Right? When A is 0, B is 1, again output is 0. Right? When A is 1, B is 0, again output is 0. There is only one occasion the output will be 1, that is A should be 1 and B should be 1. Then the output is 1. So now we have written the relevant output to each combination. That is the meaning of the truth table. අන්න අපි truth table එකක් ගහන්නේ හැම combination එකකටම තියෙන්න පුළුවන් relevant output එක ලබා ගන්න. Right? That is the meaning of truth table. Therefore, this is the truth table for the AND gate. Right? මොකද only two inputs are there, therefore there can be only 2 to the power 2. 4 combinations. So we write the combinations and we write the relevant output for all combinations. That is the truth table for the AND gate. අපි ලියා ගමු. Remember, this symbol is A, output is A dot B. Remember that, A dot B. A dot B. And this A dot B. Right? Because of two inputs. There can be 4 combinations. Right. Done neda. Right? Okay, that is the AND gate. So these are basic logic gates. So when there are two inputs, there can be 4 combinations like this. Then we can write the relevant output. So there is only one occasion that output is 1 for AND gate. Both inputs should be 1 to output to be the 1. Output එක වෙන්න නම් inputs දෙකම ඒ කියන්නේ මේකේ inputs දෙකම 1 වුණොත් තමයි මේකේ signal එක 1 වෙන්නේ. Right? නැත්තම් අනිත් හැම අවස්ථාවෙදී මේකේ output එක මොකක්ද වෙන්නේ? 0 signal එක එන්නේ. That is the meaning. Right. Okay. Okay, students. To now, any questions? මොනවද තියෙනවද ප්‍රශ්න? Yes. Right? Okay. We'll do the rest of the things by next weekend. Right? We'll discuss about the OR gate and NOT gate and combination logic gates by next week. Right? Okay. එහෙනම් අපි අද මෙතනින් නවත්තමු. ප්‍රශ්න නැහැ නේද? right? හරි. ප්‍රශ්න තියෙනවා නම් මට message එකක් හරි දාන්න. Okay, right? See you then. See you next week.
Okay, sir. Thank you, sir. Bye, sir.
Thank you.
Thank you, sir. Bye.